Okay, so let's take a look at the lid here on the fuselage in Fusion. The lid is the last piece that needs to be, last composite part that needs to be molded and laid up. So you can see here it caps the top of the fuselage and sits in between the front and the rear wing beds. And these front and rear wing beds, along with the wings, are going to be bolted down to the fuselage. So the lid is going to have a latch in the front and rear and latch into the front and rear wing beds. I'm going to go ahead and shut off the rest of the parts here so we can take a closer look. And the wing beds. Okay, so you can see the lid has a aqueduct in the top, and this is going to provide cooling air down into the fuselage, down to the ESC and the flight control board. And then if I turn on the tail cone, you can see that in the bottom of the tail cone we have an outlet for that air, that cooling air coming through. If we look inside, you can see it's just got a front and a rear bulkhead. It's right now you see it is 1.5 millimeters thick, so that's going to use that 1.5 millimeter honeycomb material that the rest of the fuselage and the wings are made out of. Now, I could just hot wire cut this, and that would be pretty quick, but I would have a lot of trouble getting this detail in. I guess I could cut it in after. So what I want to try and do with this is I want to mill this block on my CNC router. And I can use Fusion's tool pathing here for manufacturing, and you can see I've got this represents the block of foam. This is about 12.5 inches by 4 inches by about 1 inch thick. And I'm going to do this in 4 tool paths. So I've got an adaptive clearing, and this is a 1/4 inch flat bottom bit that will just hog off most of the material. And then we'll go down to a 1/4 inch round over and do some scallop passes. Now, I probably could do this a lot faster because of the foam, but I'm just going to go ahead and take it nice and slow so I don't screw anything up. And then we'll refine that path with another scallop pass with the 1/8 inch round over, just to kind of refine the curve a little bit and clean it up. And then the last pass is going to be with an 1/8 inch round over, and that's primarily just to get some detail in the aqueduct area. And then once this is done, I'll sand it up a little bit, and we'll go from there. So let's go get this chucked up in the router and start making some foam dust. To build the plug, I'm starting with a piece of rigid foam insulation, and here I'm just cutting it on a hot wire cutter. I need to mount the foam to a board backing, so I'm cutting a piece of this white melamine that I picked up at Home Depot. I'm going to use some double-face tape here to stick the foam onto the backing board. And this will give me a place to secure the board into the CNC router, and it'll also become the top of the mold. Once the board and the foam are mounted in the CNC machine, it's time to run the program and let the CNC do its thing. Now, I could have cut this shape of the foam in my CNC hot wire cutter, and it probably would have been a lot faster. But this will give me the ability to really get the detail right on that aqueduct on top. And plus I needed some practice on setting this up and running some of these CNC projects. The foam is actually very easy to cut, and I probably was overly conservative with my speeds and feeds, but this really was running on its own, so I didn't mind it taking a little extra time, and it gave me the opportunity to get some other stuff done. Once the foam comes out of the CNC cutter, it's very soft and tends to pill and have these little foam balls on it, and I need to knock those off with a piece of sandpaper. But I also need to be very careful that I don't change the shape at this point. At this point, everything looks great, and I need to firm this up a little bit so that I don't alter the shape. And to do that, I'm going to put a thin layer of epoxy on it. This will allow me to go in and start smoothing the surface without adversely changing the shape. If you do use thinner, be very careful, because thinners like acetone will destroy this foam. It'll eat right through it. After this cures, I hit it with some 320 grit sandpaper. Even with this layer of epoxy, the foam is still pretty soft, so I lay on a layer of 3/4 ounce glass. Then I look for any minor imperfections that need to be filled. To fill any of the imperfections, I'm using this 2-part epoxy fairing compound from Total Boat. Works great, and it's epoxy, so it's a 2-part mix, and it won't eat this foam. After some sanding, it's time for a coat of primer, and you guessed it, more sanding. I'm just using an automotive primer on this, and that's not the hardest material, so the finish isn't going to be perfect, but that's okay because I'll have the opportunity to clean that up in the mold once the mold is made. Once I get the plug close to where I want it, I start applying mold release wax. And here I'm just using some part all wax. And I'm going to put 2, 3, maybe 4 layers of wax on this part and on the board under it. Basically, I'm just wiping the wax on, creating a thin layer, letting it dry, and then buffing it off. I'm going to be using a PVA mold release film, but the wax really seals everything in and seals the plug before I apply the PVA. With the wax dry, it's time to start building the rest of the plug box. This box structure will allow me to build a mold that has sides on it, so it will be able to stand up on its own. With the plug box done, it's time to start applying the PVA. And here I'm just using a foam brush and trying to get a nice even coat. I've tried spraying it and I haven't had the best results, so I use the brush method, a little foam applicator, being very careful to make sure I don't have any runs or drips or any large areas that'll come through in the mold. Some of these small areas like the nacoduct can be a little tricky. You can end up with some bubbles and some drips in there. The side walls and the bottom board I don't worry too much about. They've got wax on them and the epoxy really doesn't stick to them very well anyways. Once the PVA is dry, it's time to start building the mold. And I start with a base layer or a gel coat layer. And this is just epoxy that's been thickened with fumed silica. This is Cavasil that I'm using. And this will give me a thicker material that I can use to lay over the plug, and it will also adhere to the walls and not slump. I like to add color to my molds and to this first layer, so I'm just using some color additive that I picked up, I think at Total Boat. And you just mix a little bit in, doesn't take much, and that will give you that rich red color for this first layer, which helps, helps you to see where you might be thin in some areas and to make sure that you've got good coverage. Here I'm just taking a final pass with a tack cloth to make sure that I have all of the dust out. Also, it's a good idea if you're using these cheap brushes to try and pull out any loose bristles before you get started. You hate to have a brush bristle stuck in your mold. Here I'm just pouring some of the thickened epoxy base layer over the structure. And then I'll just take the brush and start smoothing it out. You want to make sure that you get a good even coat, particularly over the foam plug section, but over the whole thing. And that red color really helps you see where you've got thin spots and thick spots. On larger molds, I'll sometimes do this in 2 layers, letting the first coat set up to the point where it's still green, but firm enough that I'm not going to disrupt the bottom of it against the mold at all. This plug is small enough that I don't think it matters. I can get away with 1 layer. Once the base layer sets up, it's time to start laying the glass. Now you want the base layer to still be green so that you get a chemical bond, but you want to be able to just leave a fingernail mark. And you don't want it too soft so that you disrupt the base layer over the plug, but you do want to still get that chemical bond. Here I'm just laying in a layer of epoxy, and then I'm starting to lay in the coupling coat. And this is the first coat of glass that goes in. I use a very fine 3/4 ounce to 1.5 ounce glass to get all of the detail and to get a good coupling bond between the base layer and the glass. Once the small pieces are in around all of the NACA, I lay in a full piece of 3/4 ounce glass. Center out and work as much of the air bubbles out as possible. You want to make sure that you trim your corners so that you can lay the glass down inside the mold and get a good fit. Once the coupling coat's done, it's time to lay in some thicker glass. This is some 9-ounce boat cloth that I have. This is going to make the bulk of the mold to give it its thickness and its strength. Again, it's just a matter of applying the epoxy and dabbing out all of the air bubbles to make sure that we get a good bond. I tend to use 3 or 4 layers of this heavy boat cloth to give a good strong mold. Once I get all the bottom in, I try and alternate between a full piece in the bottom and then strips along the outside. And overlapping the strips will give me a good solid corner and a good thick strong flange. Once the mold has cured, it's time to tear apart the box and see how we did. I'm just using a razor knife to pop off the corners. It releases pretty easily because that melamine doesn't adhere well to the epoxy. It's a little more work to get the top piece off that has the plug attached to it, so I'm using some plastic putty knives and just using them like plastic wedges. They're soft enough that they're not going to hurt the surface. There's a little bit of cleanup work to do, but all in all, it's a pretty good looking mold. Wet sanding's where I get a chance to really clean up that surface. I usually start about 400 grit and work my way up to 1500 to 2000 grit. I'm taking care to make sure that I get a good, clean, crisp finish around the NACA duct. I could spend a lot of time trying to get the bottom of the mold as smooth as possible so I don't puncture the vacuum bag, but because this is just a prototype mold, I've opted for a quick and dirty application of some tape. Now we start by putting 4 or 5 layers of wax in the mold. Again, I'm going to be using a PVA release film, so this really is just sealing the mold. The next step is to apply the PVA, and I'm just masking this area off so that I have it ready for priming. Same as we did before, I'm just applying the PVA with a foam brush and trying to make sure that I get good coverage, but a nice smooth face. This will end up being the face that the part will see. Again, I'm just using an automotive primer, and because I'm not worried about eating the foam, I'm going to go ahead and use a rattle can version of it. I find it a little more, a little tougher than the air spray version, but this will eat the foam if there's any holes. It's finally time to start the layup, and to start off with, I'm going to lay in some reinforcing. Because I've got antennas under this cover, I'm going to be using Kevlar tow. I'm also going to be using some fiberglass tow to fill in some of the tight corners. I just lay down a little bit of epoxy and then dab in the tow. Kevlar works really well. It makes for a very stiff corner and stiff reinforcement without the radio interference of carbon fiber. This can be kind of a tedious process. I'm laying the Kevlar in the tight corners at the ends, and then I'm going to lay a strip along what will be the bottom of the lid on both sides. This will give me a little bit of rigidity on the sides where it's unsupported. Also going to lay some of it around the edge of the NACA because I'm not going to be able to get the glass down in there, and also because I'm not going to be using the honeycomb on the NACA itself. Now I'm just using some fiberglass tow, and what this is just some of the tow that I pulled out of that 9-ounce boat cloth. And this makes for a nice way to fill the gaps. It stays in place pretty well and makes for a very strong, tight corner. And you could do this with some thickened epoxy with micro balloons, but that can sometimes move around a little bit when you're applying the glass, and I want to make sure that this reinforcement stays in place. Now I'm going to go ahead and start laying in some of the glass. This is 3/4 ounce glass, and I'm using small pieces of it to build up several layers on the NACA duct. Like I said before, the honeycomb is not going to go over the NACA duct itself, so really it's just going to be glass, and I want to get a few layers of glass in there to make sure that it's good and strong. Just like before, it's a matter of dabbing all the air bubbles out and getting the glass down into the epoxy. I'm also going to add this 1.5 ounce piece of glass behind the NACA duct, and this is some reinforcing because I've got a camera mount that I'm going to install here, and I want to make sure that we've got a good strong area for that camera mount. I've pre-cut this piece of 3/4 ounce glass so that it fits in around the NACA and that the corners fit. This is the outer layer of the mold of the lid, and I'm going to be using just a single 3/4 ounce layer of glass on the outside, then a piece of 1.5 millimeter honeycomb, and then we'll finish off with another 3/4 ounce piece of glass. Because this is the surface, I want to make sure that I get a very clean layup, good adhesion, and make sure that all of the glass fibers are running in the same direction to make sure we get a good strong surface. Now I've let this cure, and I'm going to come back with this piece of Scotch-Brite and scuff the surface so that we can do the rest of the layup. The reason I do this is because if we don't let this first layer cure and we put it in a vacuum bag, it's going to pull that glass up into the honeycomb. Once I've Scotch-Brited it, I just come back with a tack cloth and make sure that we have got all of the dust out. And then I mix up another batch of Total Boat epoxy. And to this, I'm adding a little bit of Cabosil to thicken it up a little bit, which is going to let me lay down a thicker layer of epoxy without adding any weight. And this will allow the honeycomb to stick into that epoxy better. So I'm just laying in a first coat of this thickened epoxy. This is where the honeycomb is going to adhere. Now it's a matter of trying to get this finicky piece of 1.5 millimeter honeycomb down into place. And this can be tough because it does fold around corners well, but these are pretty small corners and it wants to spring back into place. So this takes some fiddling. Even with the thickened epoxy, it's not enough to really hold that honeycomb in place. So I'm using some tape on the outside to kind of, push that honeycomb, hold that honeycomb down in. I also cut some small honeycomb end pieces, and these really help hold the honeycomb down into the mold. As you can see, this is kind of finicky work. But with a little bit of patience, I managed to get it down inside. This is the top piece of glass. This is 3/4 inch glass, and it's on top of a piece of perforated release film. And now I'm applying the thickened epoxy to the glass. And again, this is finicky work, especially with this 3/4 ounce glass, which is very light and wants to stick to your hands just by static. I do this right on top of the release layer, and this allows me to move it around and handle it better. I use a foam roller to evenly spread this out, and you got to be really careful with this to make sure that you get your fingers down and hold it. Otherwise, that foam roller will catch, and this thing will just roll itself around the roller. Ask me how I know. Now for the really fun part, putting the last layer of glass and the release film evenly without puckers into the mold. Now I'm putting a piece of plastic over the top. This is just going to keep the excess epoxy from leaching out into my breather cloth. And now I'm adding some breather cloth all the way around. So basically an envelope of breather cloth, and this is just going to make sure that the vacuum is pulled evenly. Then I just slide the whole layup with the breather cloth into the vacuum bag. Seal it up. start pulling the air out of it. Now it's important to make sure that I'm not bridging anywhere, so I'm just pulling up as much of the bag and placing it down inside the mold as the air is being sucked out. Sometimes I'll have to stop it and let a little air back in it and rearrange this and then suck the air out again, just to make sure that I'm not bridging anywhere. I want to get good pressure across the whole thing. Now I'll let this sit in the vacuum bag for 10 to 12 hours under vacuum. And sometimes I'll just shut the vacuum off and let it sit in there overnight to finish curing. I'm only pulling less than 1 bar of vacuum on this because that thin cloth has a tendency to pull itself up into the honeycomb under too much pressure. And now it's just a matter of pulling the whole mold apart, taking the plastic off, and then the release film. And it's important when you're taking off the release film and you're working with very thin glass like this 3/4 ounce that you don't accidentally grab the glass as well and pull it off of the honeycomb. That is really easy to do. So it's a matter of being very careful, pulling from the corners, lots of diagonals to make sure that we're pulling just the release off and not the actual fiberglass. Layup looks pretty good, and now it's time to just trim the edges off. Those Kevlar in the corner are really hard. The rest of the stuff cuts very easily, but the corners where that Kevlar is in the corner is very hard to cut. So now I'm going to try and pull it out of the mold, and I'm just twisting it a little bit to see if I can get it to release, and then taking the knife and the plastic spatulas and sliding them around the edge. It takes a little finagling. I want to be careful that I don't hurt anything, especially around that nacada, but eventually manage to pop it out. Once it's out of the mold, it's time for a test fit and some alignment for the latches. So here I'm just cutting out a notch where I'm going to be putting the latch in the back. I'm going to use a small piece of carbon fiber tube in the front as a pin, and then a plastic latch, pull latch in the back. I'm also using the rotary tool to cut out the face of the nacada so that the air can come through. I'm just using some 5-minute epoxy to epoxy the latch and the camera mount in place. And that's it. The hatch is complete, locked in place, looks pretty good. Hope you enjoyed the build. If you have any questions, go ahead and leave me a comment and I'll be happy to fabricate an answer for you. Catch you guys on the next one.